Hi, I'm Mary, and this is another magical math moment. In this video, we're going to be looking at Algebra 2 level exponential equations. This is part 2, so if you haven't watched part 1 yet, go search that up. In this video, we're going to amp it up a little bit more, and let's just get right to it. So the first thing you want to do is isolate the term with the variable in the exponent. So you can see here, I want to get this 2 to the 7x by itself. So I'm going to divide both sides by 3. This leaves me with 2 to the 7x equals 33. Now in the last video, I talked about you've got lots of methods. I am partial to saying log base 2 of both sides. Ooh, that's essentially going to cancel. I'm left with a 7x. If you're using the properties of logs, that's going to come down in front. And that's equal to log base 2 of 33. Then I need to divide that by 7. So that is what I'm going to throw into the calculator. Let's see. I've got log. Ooh, let's do this the right way. Math, alpha, math. Come on. Log base 2 of 33. And then I divide that by 7. I get 0.721. So I like to use approximately when I'm rounding. Check with your teacher to see what they prefer you to do. Okay, in the next one, we are trying to get e to the x over 2 by itself because this exponent contains our variable x. We're going to start by adding a 7 on both sides. So we get 4 times e to the x over 2 equals 12. Next, we divide the 4. So e to the x over 2 equals 12 divided by 4 is 3. Once you get to this point, you would do log base e on both sides, which is really the same thing as ln. Remember, that's going to cancel out. It's essentially 1. I'm left with x over 2 equals ln 3. Now be careful with the last part. This is division, so we're going to undo it with multiplying. I would definitely encourage you, when you're writing this part, to put the 2 in front, 2 ln 3. Because otherwise you might get confused and say, oh, ln of 3 times 2 is 6, and that's not the same thing. So you want to be very careful. So let's see, 2 ln 3 is gross, but since we're solving equations, we can have gross, that's okay. So we can say approximately 2.197 for this one. Okay, that's basically solving exponentials. It's not too bad. Where it does get a little wild is the application. So this is Newton's law of cooling. This is the equation that we'll use for this. And for those of you venturing on into calculus, there is a shortcut, but we don't get to explore that today, unfortunately. So here's your equation. T sub O is going to be initial temperature. Remember that in any formula, when you've got a sub-zero like that, that just means it's your starting value, your initial value. In this case, we're talking about temperature, so it's initial temperature. T will be over here, and that's the temperature after T minutes. And notice the little lowercase t up there. T sub R is the surrounding temperature, i.e. the room temperature. So that appears twice over here. Let me underline that. And then R is the cooling rate of the substance. Notice in the equation, it's negative R. Okay, well, let's see if we can apply this and figure out this problem. A cup of coffee has an initial temperature of 120 degrees. All right, so initial temperature. I know then that this is going to be my T sub 0. The cooling rate of the coffee is 0.05. That's going to be my R value. And the room temperature is 75 degrees. That's my T sub R. It's in the same color, so I'll circle it. How long does it take for the coffee to cool down to 105 degrees? That is going to be represented with the variable T. So let's go ahead and copy this equation, and then we'll plug in what we know and solve for the time. I don't have this one memorized, so I have to kind of keep glancing back at my notes. Okay, so T is going to be the 105. That equals the initial temperature of the coffee, 120, minus the room temperature, 75. The rate of cooling is 0.05. I don't know the time, that's what I'm trying to get, plus the room temperature, 75. Okay, I'll color code this for you just so you can kind of see like where things are going in to this function. Oh my gosh, isn't this fun? Don't you love these real life examples? Probably not. I don't blame you. It's kind of gross. All right, there we go, room temperature. Okay, so notice the room temperature appears in the equation twice. Why? I don't know, it just does. All right, so now we gotta do the mathy math. Let's see. I know I'm gonna have to get this E by itself at some point, so let's simplify here. I've got 120 minus 75, that's 45. So I have E to the negative 0.05 T plus 75. I want this term by itself, so I have to subtract 75 on both sides. And yes, I am using a calculator because if I'm gonna post this on the internet, it better be right, darn it. So I've got 30 is 45 times E to the negative 0.05 T. Next, I'm trying to get the variable out of this exponent. So I'm gonna isolate the E by dividing both sides by 45. 30 divided by 45 is a big ugly decimal. I'm gonna call it 2/3. And that's equal to E to the negative 0.05 T. Okay, now I've got to get rid of my E here. So I'm going to do log base E on both sides, or ln. That noise you hear is my cat. I don't know what she's doing, but she's knocking stuff around. She's playing. Good for her. ln of 2/3 is equal to negative 0.05 T. Finally, we're going to divide both sides by that negative 0.05. And let's see what we get. I've got ln of 2/3, and I'm dividing that by negative 0.05. So for T, I'm getting approximately 8.1. So for me, I would answer this question by saying, the coffee cools down to 105 degrees after just a little bit over 8 minutes. A little over 8 minutes. Okay. Wasn't that super fun? I enjoyed it. I hope you did too. And I think that's all I have for this one. That is all I have for this one. So I hope that this helps you with solving exponential equations as well as applying it to a real life situation. Thank you so much for watching. Please like if the video helped you, share with your classmates, and subscribe for more math content. As always, thank you for watching, and I'll see you next time. Bye.